I'm going to make a short video covering Chapter 15 fuel systems here and talk about a few things since we can't have lectures in class anymore. So just keep in mind, on a diesel engine, our low pressure fuel system has a job of supplying clean, cool, and air-free fuel to the high pressure fuel system. So by to cool some of our fuel components down, we return as much as 60% of our fuel back to the tank without running it or burning it in the engine, and that's to keep things cooled down and lubricated, so it's used as a cooling system as well as just a supply for fuel. And we need to have it all working properly because we need air-free fuel in a diesel fuel system. Air gives us a lot of problems that we'll get to a little further on into this video. So one of the biggest things for the low pressure is we have to remove water contamination from diesel fuel. That allows algae and microorganisms to grow when you have water in the fuel system, so we have to get that water out, and we'll cover how we get that done with our low pressure fuel system. We also need to prevent wax gelling with our low pressure, so that's part of our return system as well. Fuel temperature. Changes in fuel temperature can affect engine power output and cause fuel to gel. So if fuel gets too warm, then we we start losing power. If fuel gets too cold, then it starts to gel, which is when wax crystals start forming, which can stop the fuel filter up and basically shut the truck down. Okay, so fuel that is too hot loses viscosity and density, reducing engine power. So everything above 115 degrees, for every 10 degrees Fahrenheit above that, we have a 2% power loss. So we kind of need to regulate the fuel temperature. Not allow it to get too hot, not allow it to get too cold in a cold climate. Okay. Fuel tank materials. Most of our over-the-road trucks have aluminum, but we can also use plastic and steel alloys. So there are some trucks that have a steel fuel tank, especially in the medium-duty world, but our aluminum, plastic, and steel alloys are what our tanks are made out of. Okay, fuel tank ventilation is a little different on a diesel engine. It has to be vented because as fuel heats up, it expands. As it cools down, it contracts. And if you don't have a tank vented and you start pulling the fuel out of it, it can collapse. So it's got to be vented. It's a little different in the diesel world because we'll get further into this presentation and see that it takes a lot more heat for it to start producing vapors, so we don't have the same problem that automotive has. If you ever seen like a gas tank sitting out in the sun, portable gas can, you'll see a little mirage looking thing above it. That's the fuel coming out of the tank and evaporating, or out of the fuel can. So we don't really have that problem as much on diesel. So we do basically just leave our tanks vented all the time, but we have to have a rollover protection valve, so if the truck is upside down or something after a crash, we don't have fuel running out, which could cause a problem. So it's vented, but if it flips upside down, then it'll close off that vent with a little float ball so that we don't have fuel running out. Okay, fuel lines that connect all the low pressure components. They can be braided steel, steel tubing, rubber, nylon, or plastic, so stainless steel. What you don't see here is any copper, because we can't have any copper fuel lines or really components on diesel, because the diesel fuel attacks the copper and starts making it flake away, so it can give us some problems there. fuel tank on the truck. Got a fuel suction line. The sending unit's going to be in one of the tanks to tell how much fuel it has. And then we have to have a vent line and a fuel return line that returns the fuel from the engine. Okay. This is more of a light duty setup. So our big trucks don't generally have electric fuel pumps in the tank because we have multiple tanks, and that's kind of problematic, but more of a light duty thing. You're pulling this fuel from down here at the bottom. It's called the pickup, your electric pump, sending unit, return line, and suction line coming out of the top. Okay. This is more how that is on the truck, big truck. One thing we need to look at here, this suction line, we want it to pull fuel from just practically the bottom of the tank. Now you'd think you'd want that higher because you get debris and water and stuff down in here. We want to get that out of our fuel system and get it caught in our primary fuel filter so we can get it gone and not just let it sit in here and start growing algae. So our suction line will be just almost touching the bottom of the tank because that's where the water is going to be, and we want to get that stuff out of the tank and not let it sit in there. Also on the big truck, we've got a drain over here so that if we know there's some water and stuff in here on the bottom, we can open the drain and remove that stuff from the bottom and kind of get it out of the tank. Automotive hasn't caught on to that yet, and their stuff just sits in the tank. There's no way to really drain the tank other than pulling it out of the top. So I think they all should put a drain, but really you only find that in the big truck world. Okay, there's the drain we talked about at the lowest point of the tank. So since we have multiple tanks, when we return fuel, now they're going through a valve, and some trucks have a combination valve we'll get to here in a minute, but our return fuel has to come through. There's two little variable orifices in here to create an equal amount of somewhat pressure on the return line. That way it will evenly flow into each tank and not get one tank full of fuel and one tank running out of fuel. Way back in the day we had what was called a crossover pipe or hose between the two tanks that allowed it to even out and maintain the same level in each fuel tank, but federal government took that away from us because when the truck has a wreck, it would rip off that line and all the fuel would run out at the crash scene. So if you had 200 gallons of diesel fuel hitting the road after a crash, then that's really, really unsafe. So they took that crossover away. So now we have to have a restrictive in our return T here to try to return the same amount of fuel to each tank to maintain the same level in them. Sending units, we'll cover this a lot better in electrical when we get to that course, but voltage is applied to the gauge all the time. This is a variable resistor. There's a kind of a magnet set up in here. We covered that a little bit and went through HVAC, but the more ground the sending unit gives that, the stronger the magnet and the more it pulls the needle either toward empty or full, depending on which way the manufacturer built it. So the sending unit's just a variable ground. Okay, so we call that a variable resistance. As the float moves, it will change the resistance in the fuel gauge circuit, so that's what makes the needle move. Late model stuff, we can run that through the computer, so even like started off in automotive and now it's in the truck world, but instead of all the wiring being ran directly to the gauge, now the computer is getting told how much fuel's in the tank so that it can help diagnose low power problems. And part of that area so we can have the computer tells the gauge where to be as far as between empty and full, exactly where it needs to be. So instead of it wiring directly to the gauge, a lot of vehicles now it goes through a computer for the computer to know, and then the computer sends a signal to the gauge, so it's not direct wired. So little abrasive particles in the fuel is what is really hard for our fuel system. With common rail, we've gone to a whole lot higher fuel pressure. So 2600 psi when I first started in this industry was a pretty high injection pressure. Now we're at 36,000 psi. So all these little tolerances in here, clearances, have a very small tolerance to be able to build that much pressure without having leakage. So the tighter you get these tolerances, the cleaner the fuel has to be, because tiny abrasive particles can be a problem. Fuel filter requirements. Okay. We got to trap particles. 5 is pretty much the common now, although some are going down closer to 2 on the really late model engines, but most late model engines we're down to a 5 micron on the secondary. So that's going to trap very, very small particles. Fuel filters, contamination sources. Always struggle with this word, but asphaltenes, they occur naturally in number 2 grade diesel, which is what we mostly use. They're kind of a little softer particle, but they are abrasive, so they're just kind of natural little things to crude oil. It can be as small as 1.5 to 2 microns in diameter, so they're tiny little particles. High heat and oxidation increase the content of those, so that's why we have to kind of maintain a fuel temperature and not let it get too hot, because it will increase the amount of asphaltenes. So water is our most destructive contaminant in fuel. So our fuel filter's job is to get that water trapped and get it out. So as we have fuel in this barrel, is the way they're showing it, but think of it as like a fuel tank. Okay, it's here when it's cool. Now the sun gets on it, different things happen to warm it up so it expands and air escapes. That's why we have to have a vent as well. Then it cools down. We have moisture in our air, not just because when it's raining, but the moisture in our air as it cools down will be pulled into the tank as this level drops, because remember, it expands as it warms up and it contracts. So over time, with that heating up and cooling down, you'll get a little bit of water buildup in the bottom just from condensation, from moisture out of the air. So we can't have that water set in our diesel fuel. Normal fuel, less than 0.1% water. When we get water in the fuel, breaks down our fuel's ability to lubricate. It can also blow the end or the tip off of an injector, because it can't push that water through the tiny little orifices that's in the tip of this. Water can seize up injectors. It can also blow the end of them off with the high pressure trying to push water, which is thicker or more dense than diesel fuel. Fuel filters, contamination sources, water. It also helps form acid. Petroleum products and water, you can form a sulfuric acid, especially since there's some sulfur in diesel fuel naturally because it's in crude oil. So it can start forming a mild acid, causes rust. The microorganisms that can grow in diesel fuel, they can't do that unless there's water in it. So if we can keep the water out of our diesel fuel, we don't have algae and microorganisms growing in there that can cause us all kinds of problems and cost us a lot of money with common rail fuel systems. Fuel filters can separate water and fuel via coalescence or centrifugal methods. So we'll look at how that works. Now we have unfiltered fuel coming through these little holes around the outside of a filter. The clean fuel comes out of the center. So inside here we have a glass fiber filter element. Water is harder because it's denser, it's harder for it to get through this filter, so this is called coalescing. As the fuel gets pushed through, the water kind of forms here, winds up kind of dribbling down and winding up in the bottom of this filter. So that's how the coalescing type removes water. And if you notice how this goes in the outside and out this center hole, for a long time people thought it was okay to take this filter when they were going to put it on because we don't want air in the system, and they would pour diesel fuel in this center hole and fill this filter up and then install it. We can't do that anymore because our fuel has to be so clean that there's a whole lot bigger than 5 micron particles in our gas can or fuel can that we're filling that up with. So it's no longer allowed to pour this filter full because you can't pour it through these little holes in the outside here. It'll fill up really easy through the center hole, but we'll be adding contaminants after the filter, so that's not an allowed practice anymore. So if some old mechanic is showing you to do that, they're showing you wrong, because we don't do that. Centrifugal means things that are heavy. If you get something to spin, the heavier things go to the outside. So this looks a little bit like a water pump impeller, but the fuel comes through here and out, and it causes the fuel to basically spin as it comes through this filter. So by doing that, the water is slung to the outside. The diesel fuel stays toward the middle, so the water winds up out here on the bottom of the sediment bowl, and down here at the bottom where there's a drain and we can drain it. The sediment bowl is clear. They get kind of aged and where you can't see through them as much, but generally you can see the water sitting here in the bottom, and we've got a sensor over here to tell us if there's water in the fuel so we can drain it off. Water filter drain valves allow draining of water from the filter housing out the bottom like I showed you there. And we have a WIF, which is water in fuel sensor, to alert the operator to water and fuel by either a float or electrical conductivity difference, which we'll get to right here. So some have a little float, some have a electric conductivity sensor. This is the more common. Different things conduct electricity differently, so diesel fuel doesn't work as good as water. So that's how this picks up that there's water in the bottom of that and turns a light on the dash, and can even set a trouble code in the ECM and turn the service engine soon light on. Contaminant sources, bacteria and fungi, and we said that water allows both of those to grow. They grow in fuel under the right conditions. This fuel is left stagnant and basically has water in it. So you can treat fuel with biocide. Sometimes though, if you let water in there long enough and you get a lot of fungi growing in there, then a lot of the fuel system components have to be changed, and the fuel tank has to be removed and steam cleaned and properly dried to get rid of that. So it's better just to maintain your fueling system and not allow water to get in it, and then you won't have bacteria or fungi problems. Our other contamination source is wax. So as fuel starts getting cold, it starts kind of solidifying and forming wax crystals, because there's paraffin, which is what paraffin is in wax, and it's what candles are made out of. But since paraffin is in diesel fuel, At around 32 degrees, it starts becoming cloudy, so that's called cloud point. So it starts kind of forming small crystals. If it drops a couple of degrees colder than that, then it starts basically solidifying and waxing up. If we're running a really cold climate, we have to blend fuel with basically kerosene, because there's a lot lower temperature before it gels up. It's had more of that stuff removed, so we have to start blending fuels if we get to a really cold climate. To help with that waxing problem, we can put fuel heaters in here. So a lot of our primary filters have a heating element that's turned on when it's needed for cold climates, and helps keep the fuel in here warm so that it doesn't gel up and stop this filter up. Because when it waxes up, it normally stops up your primary fuel filter and shuts off fuel flow to the engine, and the truck dies. You won't be able to drive it. Let's see. So paper or cellulose is our most common, but really now when you get to the secondary, you can't really use the paper or cellulose because it's not a fine enough filtration. It is cheaper, so it's used a lot, especially on older filters or primary filters. The microglass is going to be what's used in the lower micron ratings. So paper is least expensive, microglass is most effective, most common, but higher. Absolute micron rating determines the percentage of large particle sizes a filter will allow to pass through. So the smaller that number gets, the smaller the particle it will catch. So if we had a 5 micron, the same amount of stuff coming through the fuel, these smaller ones get through because they can fit through these little pores, right? 2 micron is a lot smaller pores, easier to stop up, but it gets rid of all of that and doesn't let any of it pass. Primary and secondary filters. Primary filters are located between the tank and the transfer pump inlet, so they try to get the water off and catch the big stuff before the transfer pump. So that's normally where your primary is going to be located at. It's going to be about a 10 on modern diesel engines, so about a 10 micron for the primary, and its main job is just to catch the water and get it out of there in large particles. So that's why it's a 10. We don't want it to be too restrictive because then it can gel up easier. And on the suction side, you don't have pressure. It's like a straw where you're pulling pop out of a drink. So this suction side here, being the primary, is going to be about a 10 micron. Secondary filter is located between the transfer pump and the high pressure fuel system components. So it'll be right after the lift pump or transfer pump. And modern engine is going to be about 5 micron on that. A few of them are getting down toward 2, but generally 5 micron on the secondary filter. Cartridge filters are getting a lot more popular. They don't like throwing the metal and all the components, so you have less stuff wind up in a landfill off of a cartridge type filter. So I think metal is still a little more popular, but you're seeing a lot more of the cartridge type where you open the canister and just change out the element itself. Remember, when you're putting a filter on, if it's not installed properly, it can cause the engine to not start. So if it won't start after you replace filters, then you might not have the filters installed properly. We've already talked about the water and fuel sensor. Triggers the dash. So we have a bypass valve and a pressure relief valve on our fuel pump here. This is a gear type, which is pretty common now. So what they want us to do now, since we don't pour the fuel filters full of fuel, is put a hand primer on there. So a lot of our engines have this hand primer. Some of them have a little plunger on top of the fuel filter. We put a return check valve on the returns on a lot of our systems now. The return goes back to the tank, so we don't want to let all the fuel run back to the tank and make it where that we have air in the system when we try to start it up. So there's a return check valve in a lot of them now that as it's pressurized, it opens and allows it to return, but once the fuel system's not pressurized, it stays closed and doesn't let it leak back. Old school, I know the chapter, I think somewhere in there it talks about this diaphragm type being the most popular. I don't really think it is anymore. It was years ago, but it ran generally off the camshaft. You got a diaphragm inside here and check valves, an inlet valve and an outlet valve, and this diaphragm worked up and down off of the plunger, so it would draw fuel in. When the diaphragm comes up, this one closes off. It pushes that one off its seat and pushes fuel out. It was a pretty common one at one day, or at one time. It has a little drain hole, which is called a weep hole. So if this diaphragm gets a hole, instead of allowing this fuel to go and get into the crankcase and get into our engine oil and contaminate it, it had a little hole over here, a tiny little hole. So if that diaphragm got a hole in it, fuel would start leaking out of that, and it would tell you, just like on the water pump, that it's time to change it and not allow it to contaminate our engine oil. Okay, so the hot fuel is bad, so some engines have a diesel fuel cooler on it. Coolers are needed to keep fuel below the flash point of 140 degrees Fahrenheit, and some of our vehicles have a cooled cooler to cool down that diesel fuel. So not all diesel have a cooling system, but some do. Maintenance of low pressure fuel systems. We do a lot of checking flow. A lot of times this hose is clear, so we can see if any air bubbles are in it, and it'll tell us how much fuel it needs to produce in a certain amount of time. But the other thing is we'll be able to see if there's any air bubbles coming through our fuel system, because that gives us drivability problems and hard starting problems. Malfunctioning fuel tank vent can cause a suction to be formed inside the tank, or a negative tank pressure and fuel starvation because you can't pull the fuel out. Air leaks on the suction side. So the lines that connect from the tank transfer pump all the way back into the tank are basically at negative pressure when the engine is running, so they're a suction and not a pressure. So air can be drawn into these lines and lead to low power damaged components. So if you have a leak, as fuel rolls through that, it can actually pull more air in, and it's going to pull air. It's kind of like a straw that gets broke if you put it in your pop. There's a crack in the straw. You try to get a drink of the pop, but you get a lot of air and just a little bit of the pop. Same thing here if you get a leak anywhere in that. It'll also allow all the fuel to run back to the tank after the engine's not running, because air is drawn in where the leak is at, and then it'll give us a hard starting because it has to prime up every time to get the engine running. Air in our system is really bad because fuel kind of cushions this opening and closing on this nozzle. So when you have air in here, this hits really hard and damages the injector. So it's really a bad thing to run diesel engines out of fuel a lot. You'll tear up a lot of engine components with the air that gets in it. Okay, oil contamination of fuel can come from transfer pumps like we have discussed before. HEUI injectors have oil and fuel inside them. We've talked about this in class a couple of times getting ready for competency test, I believe. But HEUI, the injector has high pressure oil in it and fuel. Can be detected with a paper towel test or oil sample, so we can pull an oil sample and send it off if we think diesel fuel is in our oil, or you can take it and drop some on a paper towel. The oil just kind of sets in one place, but if it's got diesel fuel, it kind of expands out and gets bigger on our droplet and kind of changes a little color on the outside, and you can tell that it has diesel fuel in it. There's the hand primer I talked about. Duramax uses this a lot. A lot of the fuel filters have gone to this, but that's actually a little hand primer that you just push the plunger down, and there's a diaphragm inside there to bleed the fuel out. Just remember that when you're bleeding out a fuel system, there's always a priming vent on the filter head somewhere. If you open that up, it works a whole lot easier to prime that out. So you loosen the little priming vent and then work your hand pump. This we just talked about. The hard starting problems can include fuel leak back to the tank, air in the fuel system, lower no fuel pressure, or inaccurate fuel delivery and volume.